This presentation is on two different methods for creating well completion graphics. And we're going to use two sets of files from the gINT wiki on the Bentley website to illustrate the two methods. So this is the traditional method of making well graphics. And in this method, every time the backfill or the pipe configuration changes with depth, you create a new record here. So from 0 to 6, we have the same backfill and pipes, and then the backfill changes once more, so those three records. And now the pipe changes. Even though we have the same backfill, we have to create a new record here, and then the pipes change again, etc. And this is a part of the well graphics symbol library that supports this method. And we have shipped this with our standard sets of files. And we have many different backfills, and for each backfill we have different combinations of pipes. So if you were to add a new backfill, you would have to add as many symbols as you have different combinations of pipes that you want to support. So this is the other method. Instead of having one table in the database where you specify symbols that combine the backfill and the pipes, you have two tables instead. One for the backfill, one for the pipes. And they're totally independent. You put in your backfill with no regard as to what pipe combination you have, and your pipes with no consideration for the backfill. And here is the entire symbol library to support this methodology. You put in your different backfill symbols and different pipe symbols. So we're going to go into gINT now, and we're going to look at these items. The symbol construction, the database structure, and we're going to look at filtered lookups. If you've never used those before, they're pretty handy. And the design of the report entities themselves, and then how do we support both systems. If you've been using the traditional method for years and you've got all these projects using that method, and you'd like to switch to the new method, but you don't want to double your reports, well, you can keep the same number of reports, and with very little work, you can have the same report support both methods. All right, let's go into gINT. And here we have the files for the second method. We're just going to preview just to show you. So this borehole has no pipes, just backfill. This one has one pipe, two, and finally three pipes. Let's look at the symbol design. Here are all the symbols, and you create them using the standard way you create any symbols. And if you've never done that before, it's pretty straightforward. We have a lot of documentation in help on building composite symbols, which are material sampler, well, in general. They all work the same way. Let's look at the database design. We have the backfill table, and just a top depth and a base depth, and the graphic. And we have a lookup list. And this lookup list points to the well graphic symbol library. Notice there are no pipes here, just the backfills. And here, with the pipes, again, pointing to the same symbol library, but we don't see the backfills. And the way that's done, I right-clicked on the field, and we'll bring up field properties. We put in a lookup filter, and we're saying we only want the symbols from this library whose name starts with pipe underscore star. Star meaning any other symbols after that. And similar filter for the backfill graphics. You want the name that starts with BKFL underscore and then star. Very straightforward. Let's go back to pipe. This is a little different than you're probably used to working with. This is a child, a one-to-many child of the point table, as is backfill. And each record is defined by the borehole name and the pipe reference, which is actually not called pipe reference. We've captioned it. The actual name is item key. It's one of our standard key fields. So this is what we call a point ID item key table. However, that is not sufficient to define a record uniquely. You could have the same pipe reference 5 times to show 5 different pipe sections, for example. We only have 2 in this case, but you might want to add more. So to uniquely define each record, we've extended the key to include our own field called top depth. Call it whatever you like. And this presentation will not be going into that, but you can look that up in help about extending keys in a table. And that will make each record with unique combination of keys. Now there is another way of building this. You could build it with 2 tables. And you might want to do that if for each pipe you want to add more information. For example, the type of pipe, steel, PVC, the diameter of the pipe, inner and outer, things of that nature, the stick-up, whatever other information you'd want. Now you could add that information here, but it would be redundant. You'd be adding them for each record, and you don't want that. So another way of doing it is to have a point ID item key table that just has one record for each pipe, and then all the other metadata that you want to attach. And then there'd be a child table of that parent, and that would be a point ID item key depth table. So this field would be depth, one of our native keys. You wouldn't have to extend. We chose this methodology because it's simpler, and it also mimics the AGS structure, which is a set of files that are used by people in the UK, Ireland, Singapore, a number of other places in the world. And the AGS database structure, the AGS format, interchange format, uses this structure. And we are shipping this method with the AGS4 version 4 files. And with time, we'll be converting our other standard files to use this methodology as well. Okay, let's take a look at the report design. You just need 2 entities. Even though you might have 27 pipes, you only need 1 graphic column entity for the pipes, all of them, and 1 for the backfill. Let's take a look at each of these. The column width we've made into a variable, and we'll look at that. The reason we did that is that the width of this column also affects how we place the pipes. So the width is used in 2 places. And whenever that's the case, it is better to store that somewhere and then use it, reference that storage location in both places, or 3 places, 4 places. If you're using it more than once, that's a better way of doing it, instead of hard coding it in both places, and then if you want to change it, you've got to remember to change it in both places. But you certainly could hard code that in. We'll show you in a moment how that's done. And and it does show up, report variables do show up in the data tool here under report variables, and we only have 1. And that's how we pasted this in. Let's paste that in again. The rest is very straightforward. You just specify the top and base depths for each section. We're saying we want to take a symbol or pattern from the well library, and the name of the symbol is from that field. Everything else is pretty straightforward. The column, you give the column header and the font name and type, and the height, the column lines, and under lines, we only want a line in this column at the bottom. We don't want intermediate lines. And nothing else is used here. All right. Let's take a look at the pipe section. Here we've hard-coded the column width. It's only used in this one place. And again, each pipe section is defined by the top depth and bottom depth field, and we want the pattern coming from the well graphics library, and the name at each section comes from that field. Now, how do we make it replicate? Well, if you stopped here, it would replicate on its own. But all the pipes would be at the same location. They would be here at the left edge of the backfill graphics, which we don't want. We want them to spread across appropriately. That's handled under the Configuration tab. We have an output evaluated at each depth. And there's an expression that calculates where to put each pipe. And what it needs to place each pipe is, number one, what spacing do we want? And the spacing will depend on how many pipes we have. If we have one pipe, there's one spacing. If we have two, there's another spacing. And then the other thing that we need to know is which pipe is it? Now, the order of the pipes as they print from left to right is determined by how they sort an input. You do not have to number your pipes as we did in this example. You could use letters or you could use full words. It's up to you. But however they sort, the leftmost one in the pipe section will be the topmost one in input in the grid. So let's take a look at these expressions. Now, these are user system data expressions. If you haven't used these before, they're very handy. They allow you to store commonly used expressions in one place and then refer to them. And we're going to go there in a moment to show you how that's done, where they live. But you can look at them here. We don't have to go there. You can just click anywhere in the middle of the expression, right-click, and then read user system data. Let's put this all in one line so we can see it. So what this does is it divides the column width, which this is the second place the column width is referenced, by the unique number of pipe references, which is actually the item key field. So even though in the example we showed you there are 4 records, count unique will return 2 because there's 1 1 and there's 1 2. So there are 2 pipes. You add 1 to it, divide it into the width, and that's the spacing we need. And this user system data item figures out which pipe it is. So what this does is it counts the number of unique pipe names less than or equal to the current pipe name within the current borehole. So for pipe number 1, there's 1 pipe that is less than or equal to the name 1, etc. This @ symbol makes it a relative move. Without the @ symbol, this property would place the section at whatever the x value, whatever value comes out of this calculation. We don't want that. We want it to offset from the design position that amount. That's what the @ does. I'm going to cancel this. Now, how do we get the pipes to show up on top of the well graphics every time and white out the background, the backfill graphic, so that you can see the pipe? The way that's done is you set the print order of the pipe graphic column to a number greater than the backfill graphic column. And the default print order is 0, which is what the backfill graphics is set to. And we set this to 1. Any number greater than 0 will work. And we set a background fill. So this is the main fill here. And there we're just printing either the 2 vertical lines or the vertical lines with the horizontal line showing the slotted section. And the background fill we've set to solid, and we've set the color to white. So that's how that's done. And let's take a look at the report variable. It's in the report properties right here. You'll find that in all the reports. And you can add as many as you like. Generally, they're used for 2 things. One is for prompting the operator for more information that you can't get from the database. For example, on a fence, you could ask for the diagram name. It's also used to store expressions that are specific to the current report. Now, we don't really have an expression here. We just want to put in a width of 1.2. and we're in inches, obviously. If we just put 1.2, it would work, but at output time, it would show the report variable in a dialog when you output and ask the user, basically, do you want to change this? And we don't want that. We don't want them to change it. So the way the program distinguishes, if this value has our chevrons, our delimiters here, anywhere in the expression, we don't show it. Otherwise, we will. So that's why we put it in a calc. A calc of a number just returns the number. So it does no harm, but it hides it from showing it at output time. And let's take a quick look at data design, user system data. Oops, sorry. And here is one of our expressions here, the pipe spacing and the current pipe. Now, when you merge this in, you don't have to live with this name. We have to put this long prefix in front because it's very possible that you may have a user system data item already called pipe current. Rare in this case, but in general we're afraid of overwriting yours. So we always prefix it with these names. And you're free to change them. You can just remove that or change the name completely. On clicking OK and then saving, the program senses that you did change the name and will bring up a dialog that will allow you to automatically change all the names, all the references throughout your library to the new name. So it's very straightforward. All right. So how do we create entities within your report that will support both methodologies? I've done that by I'm going to switch libraries here, bringing up the other library, the one that has the traditional method, supports the traditional method, and I've copied that entity to a new report to make it very clear what's going on here. We just have the traditional entity here, and then the two for this new method, this split method. Now, what we need to do is tell the program only show the execute the appropriate entity under certain conditions. And we could do that with the individual entities. However, on a real form, you may have other entities that are associated with a well. You may have stick-up graphics. You may have arrows with associated callouts of text that describe each section, etc. So instead of putting these output conditions on each entity, we've put them into private blocks. If you've never worked with blocks, strongly recommend you read about it and help. It allows you to aggregate entities and then apply properties and methods to them in one place and not on each entity. So what we've done here on the old well graphics, under the configuration tab, we have an output condition. And this says only output this entity if this field exists in the database. So if you switch over to the new methodology, you get rid of the old table or tables. You may have more than one. And replace it with the new. So in that case, it won't find this field anymore. Now, if you want to keep both, there's really no need for that. But if you really want to keep both, you'd have to write some much more complex expressions. You'd have to run SQLs or counts to see if data exists in these fields. If you can go to help on that. If you have trouble, please contact tech support. But really, there's really no need to keep them both. I would remove the old tables, put in the new, and use this kind of expression. And same with the pipe and backfill entities. If this field exists, output. Otherwise, do not. So that's part of the port so that you can work them together. The other part, you would merge in our well symbols so that they have both the traditional way, and then here are all the backfills, And here are all the pipes. And now if we go to output, and we're using the new methodology here, and we'll preview, and there are 4 boreholes. There we go. No pipe, 1 pipe, 2 pipes, and 3 pipes. And now let's switch to the other project. And this only has 1 with wells in it, with a well in it. And there we go. So this way we can support both methods. So in summary, separating the backfill from the pipes makes construction of the well completion diagram simpler and faster. Making new symbols is much easier, and it also mimics much more closely how you would log that construction in the field. And the reports can be modified to support both single and double table methods. Thank you very much.